Angle and radian measures. Trigonometry is the mathematics that allows you to relate the length of sides of a right triangle to the measure of an acute angle theta. In applied mathematics, trigonometry is useful in resolving the lengths of unknown sides or the measures of unknown angles. For instance, given s and theta, we can determine the length of h. Interestingly, a circular arc with radius s and a central angle theta swings an arc, say a units long as shown, and the length of this arc is also a function of s and theta. Let's say theta equals 35 degrees. This means A is an arc that measures 35 degrees. However, it is not the length of the arc A. The length of arc A depends on both s and theta. Why and how does s affect the length of the arc? Take a moment to think about this before proceeding to the next page. The length of the arc A in the figure below is a fraction of the total circumference, c equals 2 pi r, of the circle. The measure of the arc is 35 degrees, well less than the entire 360-degree swing of a full rotation. The ratio 35 degrees to 360 degrees equals 7 to 72 is the fraction of the circumference that corresponds to the arc A. So A equals 35 over 360 times 2 pi r. 35 over 360 simplifies to 7 over 72, so A equals 7 over 36 pi r once you simplify further. Here's the arc length formula. Given a circle with radius r, if two radii form a central angle that measures theta degrees, then the length of the intercepted arc A is given by A equals theta over 360 times 2 pi r. What is a radian? Let's just say you're on a desert island all alone with only a piece of string like the one below and a lot of time. What is the most natural thing for you to do with the string? Use it as a radius to create a circle in the sand, of course. Because the string is the radius of the circle, we can use it to measure. So the radius itself becomes a unit of measure that we can then call radius units. The difference between this ruler and rulers that we've used in the past is that this one's made of string, which means it's flexible. This now allows us to measure length along a curve. Let's go back to our circle. Let's use radius units to find the length of A. So what's the length of A? Remember, 1 unit of ruler is equal to the radius of the circle. So if this is 1 radius unit, then A equals r. The arc A is equal in length to the radius of the circle r, so A equals r. Earlier, we discussed how arc length was dependent on two things, angle measured and side radius length. Let's see what happens when we use radius units instead to measure arcs. Do you notice anything? Discuss your observations. Let's bend our radii segments around the circle so that they look like this. When using radius units, the angle created is independent of the length of the radius, which means that radius units measure angles. Now we will find the length around a full circle of any radius. Using the circumference, we know that c equals pi times d, which is circumference over diameter equals pi. Diameter is also 2 times the radius, therefore 2 pi equals circumference over radius. Using arc length, we know the arc length equals pi r theta over 180, or 360 pi r over 180, which equals 2 pi r. So s over r equals 2 pi, which is the arc length over the radius equals 2 pi, and you still get to circumference over radius equals 2 pi. This is the same. In both cases, ratio between the circumference and the radius is always 2 pi, which is approximately equal to 6.28, our original radian estimate. Radius units is a terrible name, so we shorten it to radians. The definition is a central angle of a circle has a measure of 1 radian if the angle intercepts an arc with the same length as a radius. So if this length here is the same as this length here, then that angle is 1 radian. Why do radians measure angles? Let's go back to circumference and arc length. First, about how many radians are in a circle? It looks like just slightly more than 6 radii fit around the circle. We can approximate this to about 6.3 radians, or equivalently 2 pi radians. Let's use what we just found, 360 degrees equals 2 pi radians, to make conversions between degrees and radians. When we simplify, we get that 180 degrees equals pi radians. So to go from degrees to radians, we will multiply the degree by pi over 180. So that converts 60 degrees into radians. To convert radians to degrees, we flip the fraction over and we multiply the radian by 180 over pi. That can convert something like pi over 15 into degrees.